Hello. Mr. Murat, are you there?
Yes, sir.
Nice to see you here. So Murat, you are studying grade 9 right now?
Yes.
Okay. So you're going to private school, right?
Yes.
Okay. So right now, are you on holiday or you have school?
Yes. We are on holiday, not at school.
Okay. One more student is joining. Murat, may I know the reason why you are taking this course?
Yes, I know.
Why?
Because of learning math very highly and to give exam.
So how is your math at school?
I am good at math, actually.
Hmm.
I am really interested in Olympiads.
Okay, very good. Who is the second guy? Who is your
I
name?
had
Ara DK.
Yes, hello. Can you
What's
hear
your
me?
what's your name? Ara DK. Hello.
Mute my audio. Can you hear me?
Yeah, but not pretty well. Do you hear me well?
Yes.
Okay. Guys, let's do like this right now. This is our first lesson, and as you see, the class size is maximum. We can take 5 students. Okay, chatting. Hello. Hi. What's your name? Arat. Okay, Arat. Actually, as you know, we opened one group in WhatsApp, and also actually I shared the topics, what we are going to learn at the first stage. Okay, and after that, we will move to another level. I don't know, what is your level right now? First, let's just start. After a couple of weeks, I'm going to give you some tests, maybe 2-3 tests. And after the, according to the result, maybe I will speed up or I will go a bit slowly. Okay. So you need to have a look, guys. And also at the end of each class or at the end of each week, I'm going to give you some homework. You have to solve those questions. If it is too easy, you can skip some questions. And when you look at the question, if idea does not come, you need to try those questions. Actually, if possible, I suggest you to solve all the questions. Okay. So if you solve fast, it doesn't take much time. And after all, as you practice more and more questions, and also actually we will improve our thinking skill and also the speed of our thinking. And I think the students who are taking this course, as far as I know, you are interested in math and you want to do more than you do at school. And maybe, hopefully, you will actually participate in some kind of Olympiad in the future. Okay. So that is just a kind of introduction. And in this course, we have 13 topics. We have to go through these topics very quickly, so you should do your assignment as fast as possible because this is a kind of intensive course. We are going to meet only twice a week. We're not going to meet like 3-4 times. That's why you need to actually do more stuff independently. Anytime you have question, you can share on WhatsApp, or you can also just come, and when we have class, you can ask here. Okay, guys, if you don't hear me well, let me know. Okay, now I hope that you hear me well. If you just keep silence, at least I hope so. If everything is okay, we can start. Is everything okay? Murat, Arats, can you hear me well?
Yes, it's okay.
Guys, how are you actually having this class? Are you using your laptop or from telephone?
I'm using by telephone, via telephone.
How about Arat, you? Arat, can you hear me? Okay. Murad, actually in telephone, I don't think it actually displays well. If possible, I suggest you, if you have a computer or laptop, you have to join this class with laptop, because I prepared everything according to PC so that you can see well. And if you have access to writing, if you have any drawing tool, sometimes I may ask some questions so that you can just write something and give me some feedback, or you may solve some question. Okay,
Okay,
good. Guys, how we are going to have class? We are going to have class like for about 30 minutes. After that, I will give you a break for 5 minutes. And again, we will continue 25 more minutes and we will finish the class. Okay, it's 1 hour class. So our first topic is solutions to quadratic equations. And of course, actually, I'm sure you must have learned this at school. And once again, we are going to have a look at this. And you need to come to this certain level that when you look at these questions, immediately you should be able to solve these questions. It must be piece of cake for you. And I'm going to teach this, as I told you. I don't know what's your level now. So this is an intensive course. We're going a little bit fast, okay? If things are
okay,
not so clear, you just let me know. Okay, Mr. Qasim, can you just slow down, or can you just explain this thing once again? Or if you have some challenging question, you can bring this here, discuss here, or you can share with WhatsApp, and I'll prepare and do those questions here. Okay, so now let's start with quadratic equations by factorization. And as you know, quadratic equation, it has wide range of application in science, in physics, in business, in economy. Anyway, in this picture, as you see, the waterfall shown below falls down from a hill to a pond. So here we see a kind of water, right? It's just falling down from a top of the hill. And usually the motion of this particle that we call this free fall, right? It is modeled with kind of quadratic equation. Now, suppose that after certain seconds, let's say t here represents time, h is the height of the water or the distance traveled, and that's given by this equation, h equals 125 plus 2 times t minus 5t squared. The question is, can we find the time taken by the droplet of water to reach the surface of the pond? That means that the droplet of water just starts from here. If I ask you, after how many seconds does it reach actually the bottom of this hill or the waterfall? Actually, to answer this question, we need to have some knowledge or idea about solving quadratic equation. That means that here, when this waterfall just falling down and it reaches the bottom of this waterfall, right? That means that now the distance is 0. So to answer this question, we have to solve this equation. Anyway, this is a kind of motivation of this topic. Actually, it has a lot of application. All right, now we will talk about solving quadratic equation by factorization. As you know, in math, solving equations, that is the most important task, because a lot of problems, when we model them, we get an equation. And to analyze this, we have to solve that equation, right? And we will see a lot of applications. So first, let's start with solving quadratic equation by factorization. Now, actually, what we mean by quadratic equation. At high school, if you remember, any equation of this form, ax plus b is equal to 0. We call this linear equation in one
linear.
variable,
Yes,
right? So why linear equation? Because all variables are multiplied by constant number. So if I just write this equation, ax plus by, maybe here we have c, that's also linear equation, but in two variables. Here we have two variables, x and y. Again, why we call this linear? Because all these variables are multiplied by constant. We do not have the product of two variables. Like we don't have x squared, we don't have x times y, we don't have y squared. Okay, and now we suppose that we know everything about these linear equations. Now next level is quadratic equation. What is quadratic equation? Any equation of this form, right? Ax squared plus bx plus c equals 0. That's a standard form of a quadratic equation. Every time it may not appear in this form, but a lot of equations, we can reduce this to this form, quadratic equation. So after we reduce this form, now the question comes, okay, with this, so how do you solve this question? Here, A, B, C are real numbers, and you know what is real number? Any number that we can actually place on the number line that's called a real number. And here, A is not equal to 0. We have to add this condition. Why we have to add this condition, Murat?
A non-equal to 0, these conditions and real numbers, yes?
Yeah, why actually I should state here that A is non-zero number here. Why?
Because if A will be is because A is equal to 0, it doesn't be a quadratic equation.
Very good, because if A equals 0, here we have 0 times x squared, and x squared disappears from this equation. It just becomes linear equation. We already studied about linear equation, right? So actually, we should actually study something different from linear equation. That's why this condition is must. A should be different from 0. Anyway, so that is our quadratic equation. So actually, we'll just begin this chapter by revising what we have learned. Actually, I'm assuming that because usually we teach students how to solve quadratic equation by factorization in grade 7 and 8. And after that in grade 9, a more general way using the formula. Okay, so now suppose that we are given these quadratic equations. As you see here, they are not in standard form, maybe question B standard form. And how do you solve this by factorization? Factorization means that actually, if you are given any quadratic equation like ax squared plus bx plus c, and we assume that we suppose that it's possible to write this quadratic or expression as a product of two linear expressions. Like for example, let's say here we have mx plus p times nx plus q. Now on the right hand side, we have 0. And we know that in algebra, if the product of two numbers like a times b is equal to 0 in real number system, in some different systems, actually it's a bit different. In real number system, a is a real number, b is a real number. If the product of two real numbers is equal to 0, then either a must be equal to 0 or b must be equal to 0, or maybe both can be equal to 0, but at least one of them must be equal to 0. Only
Yes.
under this condition, then this product can be equal to 0. Using this idea, now I can solve this. Since it is so, we have the product of two expressions here. Then we are claiming that actually that thing, that mx plus p times nx plus q is equal to 0. Then this mx plus p must be equal to 0, or nx plus q is equal to 0, right? And we know how to solve this from here. X equals okay, what happened? Okay. Now from here, we can get the first root, x equals negative p over m, and the second root of this equation, x equals minus q over n. Anyway, using this idea, if you solve this a, for example, to x squared equals 7x, take 7x to the left-hand side, 2x squared minus 7x, that's equal to 0. So how do you factorize this? Since we have only two terms, we should just find a common factor and take this out. So here, common factor is x. So here we have 2x minus 7, that's equal to 0. So from here, either x should be equal to 0 or 2x minus 7 should be equal to 0. Dot, dot, dot. What is the solution of this equation? The first root is 0, and the second root is, what is it? 7 over 2. And how about question B? Let's use different colors so we can differentiate. How about question B? 3x squared minus 5x minus 8. 3x squared minus 5x minus 8 is equal to 0. Murat, can you factorize this? How do you factorize this?
Just like that. We must find the two roots. That's why we take the product of roots is equal to minus 8 over 3. Then we took this the um, the sum of the roots is minus 5 over 3. That's why we must find it like that. Then
Okay, thank you.
uh,
As actually we are looking for the roots, and here assume that just quadratic expression. How do you factorize this? One method is, what is it? Uh, Here I should write this 3x squared as a product of two terms. Actually, since 3 is prime number, the only way is we can write it as 3x times x. And also this 8, I should write this as a product of two numbers. And when we cross multiply and add them together, it should give us
yes,
middle term, right? And in this way, we can
yes,
factorize this. So what is it? This 8 maybe 2 times negative 4 or 4 times negative 2. So since it is negative 5, if I write here 2, it is 6, it is 4, doesn't work. How about 4? It is 12, and all right, doesn't work. How about 8 and 1? It works, right? So here we have negative 8, and here we have 1. 3x times x, 3x squared, negative 8 times 1, negative 8. When you cross multiply, as you see here, 3x times 1, 3x plus negative 8 times x, negative 8x, their sum equals negative 5x. So we can factorize it as 3x minus 8 times x plus
it's
1
plus
is
1.
equal to 0. And from here, dot, 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 what is the first root of this equation? That is 8
8
over
over
3.
3
And the second root,
minus 1.
negative 1. Very good. And how about C? All right, let's use, what is it? Green. And how about C? Sometimes students get confused. On the right-hand side, we don't have 0, right? So the only way is we have to expand it first and take this 5 to the
Yes,
left-hand side, simplify, bring into the standard form, then just follow this method. So if we expand this, 2x times x, 2x squared
x quadrant
minus 4x
or
minus 1x,
minus
that
5
is minus 5x. And here we have plus 2,
plus
take
2
5 to the
minus
left-hand
5
side,
minus 3.
minus 3 is equal to 0. Good. So now, Murat, can you tell me how actually I can write this 2x squared and 3 as a
Okay,
product of two terms?
okay.
And 2 is a prime number, 2x and x.
2x x
How about
minus
3?
1 minus 3. I can find like that. 1 minute. Uh,
Minus 3.
Minus 3 and 1, right? Or 1
yeah,
and minus
minus
3.
3.
So make sure that when you actually multiply them together, we get this corresponding terms. Anyway, so if you just multiply, cross multiply them, 2x times negative 3, that's equal to negative 6 plus 1 times x. It is x, their sum is negative 5x. So from here,
Yes,
I can factorize it as 2x plus 1, and here we have x minus 3 is equal to 0. So dot, 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 the first root. Actually, this dot, 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 actually in math we use this. It means
yes.
therefore, that this dot, this triangular dot, 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 it means it is therefore. Therefore,
Mentally,
the
mentally,
roots of
yes.
this equation is, what is it? Negative 1 over 2. And the
Minus
second root is
3.
positive 3. Okay?
Okay.
All right. Another example. I think the 3 equations examples enough for solving quadratic equations by factorization. Find the quadratic equation x whose roots are 2 and negative 3 over 4. So here The roots are given, so we need to construct a quadratic equation. Right here we have the first roots, and here we have the second roots. And usually, since actually these are the roots, how do we form the equation? It must satisfy this equation. Right here, x minus x1 and the x minus x2 is equal to 0. This is how we construct. As you see here, it is quadratic equation because if we expand this, we will have x squared. That's the highest degree
Yes.
of this polynomial. And if you substitute x1 for x, x1 minus x1, that's equal to 0. So 0 times anything that's equal to 0, it's done. And how about if you substitute x2 for x, x2 minus x2 is equal to 0, 0 times anything. So that is how we construct quadratic equation if roots are given. Actually, this idea works for any equation. How about if I ask you, can you construct a cubic equation whose roots are x1, x2, and x3? At the time, our guess, actually, that educated guess would be, what is it? X
X
minus
minus
x1,
x1,
x
x
minus
minus x2,
X
x2,
minus
and
x1.
x
x minus
minus
x3.
x3 is equal to 0. And after that, we can just expand and simplify. We will get our cubic equation. Anyway, so let's get back to this example. Here we have x minus, what is the first root of this equation? It is 2. Let's substitute here 2, and x is our variable,
It's
minus, here we have
plus.
minus 3 over 4. So that's plus 3 over 4 is equal to 0. So now we need
We
to write
must
this in
expand
standard form, right? So x times x, x squared
x
X
plus 3
uh,
over 4, x
minus 1
minus 2x minus 2 times 3 over 4, that's equal to
3
3
over
over
2.
2. That's equal to 0. And if you simplify this, here we have x squared, and 4 times 2 negative 8, 3
5
minus 8. So
over
here we
2.
have minus 5 over 4x minus 3 over 2 equals 0. And we have fraction. We better just leave this in
Multiply 4.
coefficients and whole numbers. So multiply by 4. So here we have 4x squared. Let's say dot, dot, dot. Therefore, our equation is 4x squared minus 5x minus 6. That's equal to 0. So this is the quadratic equation whose roots are 2 and negative 3 over 4. Arat, are you there?
Yes.
Arat, are you also actually joining this class with your telephone or with laptop or PC?
Computer.
So why I cannot see your face?
What?
Can I see your face?
Because it's the first time I'm using Zoom, I joined fast, so I didn't turn on the accession to my camera.
Okay, very good. Anyway, also I'm recording this. I'm going to open one channel on YouTube and upload all the videos there. And sometimes actually you may need to have a look. Now let's continue. So solutions by completing the square. Now this is the first step to generate the general solution for a quadratic equation. So what is the idea? This is another method. Actually, using this methods, we are going to have a formula to solve any quadratic equation, because factorization, it does not work all the time, because if the roots are not whole numbers, I mean, using factorization methods, it is not so practical. Even it doesn't work. And sometimes the roots of a quadratic equations cannot be obtained by simple factorization. So a more general method is used to obtain the roots of the quadratic equation. That's what we are talking about here. So actually to do this, if you're given any quadratic equation, let's say here we have ax squared plus bx plus c. So actually our task, it's a little bit challenging. It will be, can I just convert this into this form? Something like this. Here we have maybe x plus p squared, and here we have q. Can I just form this into this form? If we can do so, suppose that on the right-hand side, maybe I can just write here minus q. Actually, it doesn't matter. Just let's actually stick to the consistency. On the right hand side, let's say we have 0. Then I can take this q to the right hand side. Here we have x plus p squared is equal to q. And something squared on the left hand side, and here we have q, right? And when actually this equation can be equal to q, it depends on the sign of q, because if q is positive, then we will have two different answers. If q is equal to 0, we will have coincident rules. That means that the roots are real and they are equal to each other.
Wow.
And
Yes.
if q is less than 0, it doesn't have any roots.
Real.
Okay. And here we have geometric representation of completing the square, because if we have like x squared, for example, let's say we have two terms plus bx. That is what we are going to practice here. Here we have something like this. Here we have, let's say, f of x equals x squared plus bx. And I want to have this something squared here. We call this perfect square because x plus p squared is the square of some kind of algebraic expression. Then the question comes, what should I add here so that I can have perfect square here? What do we add here? As you know, actually here we have equal x squared. I should try to bring into this formula, that is a plus b squared. What is it? Is equal to a squared plus 2ab plus b squared. Any expression, if it is in this form, we call this perfect square in algebra. Why? Because it's a square of some kind of algebraic expression. So this b, I'll just make a trick here. I mean, simple manipulation. For b, I can just write it as 2 times b over 2 times x, right? And to be able to write in this form, I need the square of this b over 2. So here we have b over 2. Let me just add it.
Yes.
We call this manipulation in math. So it is b over 2 square. Now, as you see here, the first three terms, right? It forms a perfect square. So I can just write it as,
it's
here we have
b over 2
x plus b over 2 squared minus b over 2 squared. Now, if I just denote this b over 2 by p, the whole thing b over c squared by q, we will have this form. And here, just geometric representation, how should we understand this visually? Okay, see here we have x squared. That means that it's a kind of area of this small square whose side is x. And here we have bx. That means that the height is x and length or width is equal to b, right? If you just combine this figure together, we will have x squared plus bx. Now, if I just divide this thing into half from here, and just cut it off and put here horizontally, and just the second piece, place it here. As you see here, something is missing here. Something is missing here. Now, what is the length of this figure? It is x plus b over 2. And how about the height? It is x plus b over 2. But here we have something missing here. So I need to add some kind of small piece here so that it becomes small square. That is the algebraic representation. Here I'm asking, what should I add here so that it becomes perfect square? So what is missing here? So this thing is missing here. That is because this length is b over 2, and also this height is b over 2. So I need to add the small square whose side is b over 2. Then actually it becomes a perfect square. Anyway, so we will talk about this. Solve the following equations. Let's just start with this. The simple equations. Again, here we have x plus 2 squared equals 16. That means that what number square is 16? Usually, how do you solve this equation? Usually, we need to solve this by factorization. Because if we are given something like this, for example, x squared is equal to, let's say, a. And a is, let me just write here, a squared. A is anything, because we know that if a is negative, it doesn't have real roots. How do you solve this? Actually, short way is dot, 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 x is equal to plus minus a. But actually, how do we reach this actually conclusion? We are actually solving this by factorization method, right? Here we have x squared. Take this a squared to the left-hand side. Here we have minus a squared, and here we have 0. So now I can factorize it.
X minus a, x plus a.
Very good. X minus a times x plus a, that's equal to 0. Now from
There are two
here,
rows.
x equals a or x equals negative a. But actually, we are just doing these steps mentally and just reaching the conclusion directly. Okay. Actually, we are going through these steps, and anyway, we just reach the same, how to say, the same results. That's why we don't have to do everything. We don't have to write down every step. That's math, because always we try to do everything in the simplest way, in the shortest way, and in the shortest time. So similar to this, if you solve question A, here we have then x plus 2, right? Squared equals 16. So that means that this x plus 2 should be equal to 4,
Plus minus 4.
or x plus 2 should be equal to negative 4. So from here, dot, 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 x equals 2, or let me just write x1, x2, here we have
Minus
negative 6. In similar way, also you can solve question B. All right, let me have a look at time. It's 9:31. Guys, 5 more minutes. After that, we'll have some break, maybe 3-4 minutes, okay?
Okay.
Okay, what must be added? What must be added to each of the following expressions to obtain a perfect square? Again, perfect square means that is a plus b squared, right? Which is equal to a squared plus 2ab plus b squared. All right, here we have x squared. This 5, we can just write it as, because in the formula we have 2,
Multiply
5 over 2.
2x.
So what must be added here? We need to add that thing, right? 5 over 2 squared.
Yes.
So that it becomes a perfect square. Now I can just subtract this, 5 over 2 squared. So the answer is dot, dot, dot. We have to add 25 over 4 to this expression, so that we can, actually it becomes a perfect square. And how about in question B? In question B, here we have a squared plus 2 times k times a. Already we have 2 here, we have a here. Just we need to add, what is it?
K
K
quadratic.
squared and minus k squared. So now the first three terms form a perfect square. So our answer to this question is, we have to add k squared to this expression so that it becomes a perfect square. And how about C? In C, c squared minus 2 times 2 times c. So actually the square of this number is missing. So we need to add 2 squared minus 2 squared. So dot, dot, dot. We have to add 4 to this expression so that it becomes a perfect square.
Yeah.
Guys, let's have a break, maybe 4 minutes. It is 33, okay? Or 4 minutes. After 4 minutes, I will continue. I'll just pause and leave it like this. Okay? 4 minutes
Okay.
break. Let's drink some water. All right, guys, I'm back. Let's continue. If you are there. Okay. All right. Chats, what's your name? All right, the surface count 3 years, very good. Okay. Solve the equations. So solve the equations here means we need to use the completing square method to solve these equations. And after that, we'll actually generate the general formula. So as I see here, first we have to bring this into the standard form, right? So if you just multiply by negative one, so what do we have here? A x squared minus 16x plus 63 is equal to 0. But here we need to solve this by completing the square method. So here we have x squared minus
16x
2 times 8 times x. So we need this 8 squared, right? So actually I need 8 squared and the 63, here we have negative 1 equals 0. So here we have perfect square, that is x minus 8 squared is equal to 1. From here, x minus 8 equals 1, or x minus 8 is equal to negative 1. Dot, dot, dot. The first root of this equation is 1 plus 8, that is 9. And the second root is negative 1 plus 8, that's equal to 7. And how about b? In b, x squared plus 2 times 2 times x. So we need the square of this 2. So this 8, I can just write it as 2 squared plus 4 is equal to 0. So the first three terms, the perfect square, I can just write it as a square of x plus 2 squared and take 4 to the right hand side, negative 4.
There are no real.
On the right hand side, we have negative number. On the right hand side, is something squared is always non-negative. And non-negative number is never equal to negative number. And that's why we just write that this equation has no real roots. Dot, dot, dot. This equation has no real roots. Okay, that's it. So now we will talk about general solution to a quadratic equation using that method, completing the square methods. And actually, I think you know the general equation, right? If you're given any quadratic equation, ax squared plus bx plus c is equal to 0. The general formula is, what is it? X equals negative b plus minus square root of b squared minus 4ac over 2a. And how do we do this? You'll just get that formula. I mean, once again, here I'm just trying to give you some idea. Maybe you know that one, but you might, maybe even you can actually generate the formula. But here we will have kind of discussion and have a look one more once again. And actually at the beginning, we talk about linear equation, right? Like for example, ax plus b, that's equal to, let's say, c. Now, if I ask you, make x the subject of the formula, what does it mean? Make x the subject of the formula by applying some algebraic manipulation. can you just leave x alone on the left hand side? And on the right hand side, we will have expression that does not involve any x. So that's very easy, right? Just subtract b from both
Yes.
sides. Now we will have here ax is equal to c minus b. And if I divide both sides by a, then here we have x equals c
Over A.
minus b over a. Okay. But in math, as we just increase the degree of this polynomial, because here we have a polynomial, that the first degree polynomial, right? Let me just here, first degree polynomial. Here we have ax plus b. Name on the right hand side, I can write 0 or polynomial equation. And the second degree, let's say here we have ax squared plus bx plus c. And I can just write here third degree, blah, blah, blah. As the degree increases, you will see that actually making x the subject of the formula on the right hand side, we have 0 here. It gets harder and harder. When it is 3, it's pretty hard. 4, very hard. 5, almost impossible. So now what we can do is we can actually generate a formula for quadratic equation. So we are talking about this quadratic equation, ax plus bx plus c. On the right hand side, we have 0. Every time going actually through those steps, it's not practical. That's why we are going to have one formula and just apply this and use it. So since in the definition we have this condition, a is not equal to 0. Since we know that a is not equal to 0, I can divide both sides by non-zero number. If you divide both sides by a, what do we have here? Here we have x squared plus b over ax plus c over a is equal to 0. So here, as you see, as you know, in the formula we have 2, so I need 2 here. So actually also we'll manipulate this, 2 times b over 2a, and here we have x. Now what we need here, I need the square of this b over 2a, right? I just add and subtract. So here we have b over 2a squared
Over A.
minus b over 2a squared. And still here we have c over a, and that's equal to 0. So now we got perfect square. So we can just write it as x plus b over 2a squared, and take everything to the right hand side. Here we have b squared, right? And if you simplify these two things, and 4a squared, let me just write it first, b squared over 4a squared minus c over a. If I write one more time, what do we have here? X plus b over 2a squared. That's equal to, here we have 4a squared, b squared minus 4ac. All right, this is important points. On the right hand side, we have something that is non-negative because of the square. Maybe it can be 0 or it's always positive. And on the right hand side, we have a fraction and a denominator for a squared. Also, it is always positive because a is non-zero number, and non-zero number squared is always positive. So here we may have problem here, this expression. And that's why actually we actually attach a special name to this. This determines either actually whether this equation has solution or not, right? So we call this discriminants. That, let me just denote this by delta. Let's say is equal to b squared minus 4ac. That is a discriminant of this equation. So now, depending on the value of this discriminant, we can actually, this equation may have solution or it may not have solution. So the first case is, what is it? Let's say discriminant that delta is positive. Then what do we have here? Then here we will have that x plus b over 2a. On the right hand side, we will have square root of delta over 2a, because for a squared, if you just take square root of this expression, we have 2a. Take to the right hand side and simplify, dot, dot, dot. The roots of this equation will be 2a, the same denominators, minus b plus square root of delta over 2a. Murat, what is missing here? We made one mistake here, not mistake, but something is missing here. What is that thing?
It can be -2.
No, there's a mistake here. There's a mistake here. Can you correct that mistake?
In the right-hand side, yes.
Yeah. In the final answer here, something is wrong here. What is that thing?
The wrong.
Can you see the mistake? Actually, that mistake, actually, we made a mistake here. All right, if you
There should be
remember,
x squared.
yeah, if you remember, if x squared is equal to a something squared or a whatever it is, I can just write maybe a, okay? So here, our a is positive. And what is x here? X equals plus minus square root of 8, right? We did this already, because if you just factorize, we'll have something here. So here we have something squared equals, actually here we have delta over 4a squared. So if you take square root of both sides, then here we will have plus minus. And here also, here we have plus minus. That means that if you just take plus, we will get the first root. If you take the minus, we get the second root. Here, of course, we have two. Actually, in math, we just say that here this equation then has two distinct real roots. Distinct means different. They are not equal to each other. They are real number. That means that numbers are on the number line. And the roots is the solution. Anyway, let's continue. How about the second case? The second case is, what is it? Delta is equal to 0. That means that on the right-hand side, we have 0. And immediately here we have x plus b over 2a squared will be equal to 0. From here, what is x1 and 2? We will have minus b over 2a. And here we say that it has real roots. It has two roots, but they are equal, or they are coincident roots. Coincident means they're coinciding each other. Both actual roots are on the same points. And the third one, because some students, even people, even some math teachers, they just get confused. Why should we mention this? Okay, can't we just say that it has a root? The root is just minus b over 2a. Yeah, you can say that, but here by saying that it has two equal roots, we are emphasizing that we are talking about quadratic equation. Okay, if you just say that the root is b minus b over 2a, okay, that's the solution of linear equation or what? So when you just say that coincident two equal roots, we are emphasizing that we are talking about quadratic equation. Anyway, the third case is, as you know, if delta is less than 0, on the left-hand side, we have non-negative number. On the right-hand side, we have negative number. Then the equation has no real roots. It has roots, but they are complex, right? They are not real. Complex, but here, yes. We are interested in real roots, so they are not the roots. Anyway, the general solution is this. And of course, using the formula, a lot of students can do this, but thinking and looking at things from this angle, from this perspective, is quite different. That means it's just going a bit deep into this concept. Anyway, let's just do one question to warm up, or how to say, just to digest what we have done in the previous slide. Solve for x squared plus 3x minus 2 equals 0. Giving you answer, correct the three significant figures. Okay, the significant means actually it is importance. So that means to just keep the most important three digits. Anyway, so it's already in standard form. Here a equals 4, b equals 3, so c equals -2. First, let's find delta, discriminant, that is b squared. That is b squared minus 4ac. What is b? 3. So it is 3 squared minus 4 times a is 4, and c is -2. which is equal to 9, 16, 32, 32 plus, that is 41, which is positive. That means that we have two positive roots. I mean, two real roots, not positive. We don't know it's positive or not. Actually, one is positive, one is negative because of the C, right? Anyway, so what is the first root then? The first root is negative b, which is minus 3 plus square root of 41 over 2 times 4, which is equal to 8. And the second one is, we call this conjugates, minus 3 minus square root of 41 over 8. But now to write the answer according to this, it says correct the three significant figures. We need to use our scientific calculator. So, all right. So what we have here, fraction. I'm using this scientific calculator, but if you have, you can use it. If you don't have, maybe online. Anyway, so it is minus 3 plus, what is it? Plus square root of 41 over 8. So when we just get this, the answer is 0.0.42539, 539 dot dot. But here, what do we mean by three significant figures? What? Do you know what is significant figures?
What means?
What do we mean by three significant figures, or two significant figures, or five significant figures? Anyway, actually, to write a certain number. Yeah, Arat, what did you say?
3 digits with 0.
Yeah, actually, starting from the first non-zero number, just keep 3 digits. It means this, right? But starting from the first non-zero number. Here, what is the first non-zero number? The first non-zero number is 4. So we have to keep the first 3 digits and we have to round off. So also this 3 is less than 5. So actually that is equal to 0.425. Correct the 3 significant figures. And how about the second one? If I just change this plus sign into minus, okay, minus 3 minus square root of 41 over 8, that's equal to minus 1 over 17539 dot dot. Continue. So we need to write this correct. There's three significant figures. The first non-zero digit is 1 here. So I should keep the first 3 digits and round off. So this 1 minus 1 point, since it is 5, 1, 8. Correct the 3 significant figures. Okay?
Okay.
Good. Let's continue. Guys, these equations, we can solve them yourself. Now you know the formula, right? And maybe we can try together, because these are a bit different questions. One, we have two coincident roots. One, we don't have a roots. As you see here, the first one, at least let's just find a delta. Delta equals 42 squared. We have always squared, so we can just ignore this negative sign. Minus 4 times 9 times 49. Sorry, 49, right? And which is equal to, what is 42 squared? 42 squared minus 4 times 9 times 49. That's equal to 0. That is equal to 0. Now we will get the two roots, it will be equal. How about in question B, if you find delta, here we have 10 squared minus 4 times 5 times 13, which is equal to 100, minus 20 times 13, which is equal to 230. That's equal to minus 160. Actually, it's 260. So that is negative. That means that this equation has no real roots. Okay. As we have 5 minutes, let's just talk about this. Maybe we saw one question, and after that, I will finish the class for today. Now, it is about equations reducible to a quadratic equation. Now we have a lot of equations, a lot of problems. When we just model them, you will see that we can see that actually it is like quadratic equation. It's not like in the form ax squared plus bx plus c is equal to 0. But if we just do some manipulation, or if we just simplify this, we can reduce them into quadratic equation. So actually we are going to talk about this kind of equation. For example, if you look at this, 6 over x squared plus 13 over x is equal to 8. Is it a quadratic equation? It's not, because in the definition, how did we define a quadratic equation? It must be like this, right? If it is ax squared plus bx plus c is equal to 0. If the equation is in this form, then we call this quadratic equation. But that thing here, this equation is not quadratic. But let me just introduce some variables. If I denote this 1 over x by y, then this 1 over x squared will be y squared. And if we just substitute this into this equation, what we have here? Here we will have y squared, right? Y squared plus, 6y squared plus 13y, and minus 8 is equal to 0. Now it becomes a quadratic equation. So to solve that equation, first, by solving this equation, we can solve the given equation here, right? Anyway, this kind of equation, we call them equations reducible to a quadratic equation. Let's see one example. That is that example. So using that auxiliary variable, we call this in math auxiliary variable. Auxiliary means helping. Like in English, you just say that I am going to school. That am is an auxiliary verb. It's just helping the main
Auxiliary
verb.
verbs.
Yeah, also here it says in math, sometimes we may introduce some extra variable so that actually we can solve the given problem easily. So we call this auxiliary variable. Anyway, so let's say y is equal to 1 over x. Then here we have 6y squared plus 13y minus 8 is equal to 0. And by using the formula, here we have 13 squared minus 4 times 6 times negative 8, which is equal to 169 plus 24, 8 times 24. I think it is 8 times 24, it is 192,
140. Yes.
which is equal to, if you add them together, 200, 350, 361. So from here, y1 is equal to, here we have minus 13 plus square root of 361, that is 19, over 2 times 6, that is 12, which is equal to 6 over 12, 1 over 2. And y2 equals minus 13 minus 19 over 12, that is minus 32 over 12. If you just simplify by 4, I mean divide numerator and denominator by 4, what we have here? 8 over 3. So now from here, the first root of this equation is, because it's equal to 1 over x, that's equal to 2. And the second root of the equation is minus 3 over 8. And how about question B? Guys, let's also solve this and finish our class with this. In question B, usually in this kind of equations, on the left-hand side, we have one fraction. On the right-hand side, we have one fraction. What is it? We call this kind of proportion, right? Because this equality, A over B equals C over D, we call this proportion. And how do you solve this kind of equations? We need to cross multiply, right? And take everything to the left-hand side and solve this. So
Times D.
if you cross multiply, here we have 3x minus 15. On the right-hand side, 2x times x, 2x squared,
X
8x, right? So it is 2x squared minus 8 minus 3 minus 11x
plus minus
plus 15, that's equal to 0. Or from here, delta equals 11 squared minus 4 times 2 times 15, 121 minus 120, that's equal to 1. So what is x1? x1 equals 11 plus 1 over 2 times 2, it is 4, that's equal to 3. And the second root of this equation is 11 minus 1 over 4, that's equal to 5 over 2. dot dot dot. The roots of this equation are 3 and 5/10. Okay. All right, Murat and Arat, I think you have a telephone. These days, actually, everybody has a phone. Even babies
Yes.
have telephone. So now I'm going to share homework. Guys, I don't know how busy you are, but as I told you, I suggest you to solve all the questions if possible. And some questions, you should come to a certain level that just look, when you look at the question, idea comes. And
Okay.
so I will give you one homework, and also try to solve as many questions as possible. Today is Tuesday. We are going to meet when? On Friday, right?
Right.
Yes,
Yes.
we have class on Tuesday and Friday. Guys, nice to meet you. If you have any question, you can just join our group in WhatsApp and through Mr. Adalat, or if you just send me your number, or you can add my WhatsApp number, that is +85595982881. This is my WhatsApp, Telegram, telephone, everything is my number. Okay. And you can just add this. Hi, Mr. Qasim, I'm Murat or Arat. I am grade 9, so I will add you to that group. All right, guys. Thank you very much. I will also share your
Thank you
homework
very much, sir.
in this group.
Yes.
Okay. See you on
Okay.
Friday. Nice to meet you once
Thank
again. All right. Bye bye,
Nice to meet
boys.
you.
Bye
Bye.
bye.
Bye.